Most people look up at the stars and imagine distant worlds as peaceful, serene. Blue skies. Green fields. Oceans. They imagine planets like ours, only a little different. But the universe has a much darker imagination. There is a world, 63 light-years away, where the sky is not blue. It is a deep, glowing sapphire, beautiful at first glance. But that color is not a reflection of oceans. It is the glow of a hellish atmosphere. On this world, the rain is not water. It is glass. And it does not fall downward, it falls sideways. At thousands of kilometers per hour. This is the reality of HD 189733b. To understand how a planet produces glass rain, we have to journey into its atmosphere, to the very top. HD 189733b is what astronomers call a hot Jupiter. It is a gas giant, similar in size to Jupiter, but it orbits its star incredibly close. 10 times closer than Mercury orbits our Sun. Its year lasts just over 2 Earth days. The planet is tidally locked. One side, the day side, is permanently facing the star. The other side, the night side, is permanently dark. This creates a temperature contrast so extreme that it defies intuition. The day side can reach over 900 degrees Celsius. That is hot enough to melt lead, silver, and even aluminum. The night side, meanwhile, is far cooler. This difference is the engine that drives the planet's weather. And it is unlike anything on Earth. The atmosphere of HD 189733b is rich in silicates. These are minerals that form the basis of sand and rock on Earth. On this planet, the dayside heat is so intense that it vaporizes these silicates directly from solid rock into a gas. Imagine sand on a beach instantly turning into steam, but that steam is the building block of glass. This silicate vapor is carried by immense winds toward the cooler night side. As the vapor travels, it crosses a critical temperature threshold. It begins to condense. But it does not condense into liquid droplets like water. It condenses directly into microscopic grains of glass, solid particles that are sharp, angular, and incredibly hard. This is the moment the rain is born. Now, here is the part that challenges intuition. On Earth, rain falls down because of gravity. The droplets are heavier than the air around them. On HD 189733b, gravity still exists. But the wind is the dominant force. The planet rotates so slowly that the atmospheric circulation is driven entirely by the temperature difference between the day and night sides. This creates a global jet stream that howls at over 8,000 kilometers per hour. That is 7 times the speed of sound. When the glass particles condense, they are not heavy enough to resist the wind. They are immediately caught in this supersonic current. They do not fall. They are blasted sideways, horizontally, at thousands of kilometers per hour. The glass rain does not drop. It flies. The particles themselves are tiny, microscopic shards. But in this wind, they become a corrosive sandblasting storm. They carve into everything. Any hypothetical surface on this planet would be scoured smooth in minutes. The glass, once formed, continues to circulate around the planet. It is trapped in a cycle. It is carried to the dayside, where it melts again into vapor. Or it is carried back to the night side, where it recondenses. The cycle is perpetual. It has been running, uninterrupted, for billions of years. This is not a storm. It is a permanent state of existence. How did we discover this? In the early 2000s, the Hubble Space Telescope and the Spitzer Space Telescope observed the planet as it passed in front of its star. They analyzed the starlight filtering through the planet's atmosphere. Different molecules absorb light at specific wavelengths. The signature was unmistakable. Silicate vapor. Magnesium silicate. Iron silicate. The data confirmed the presence of high-altitude clouds of tiny glass particles. Later observations with the James Webb Space Telescope refined the picture, revealing the temperature and wind patterns. We did not just guess. We measured the chemical fingerprint of a hell that rains glass. The blue color of the planet was a surprise. Initially, some thought it might reflect oceans. But the scattering of blue light by the high-altitude glass particles creates a specific hue. The planet looks like a blue marble from space. But it is a false illusion. It is the same reason Earth's sky looks blue. Rayleigh scattering. On HD 189733b, the scattering is done by tiny glass crystals. The most beautiful color in the universe often hides the most violent reality. One might wonder, could this happen on Earth? The answer is no. Earth's silicate cycle happens very slowly, over millions of years, through plate tectonics. On HD 189733b, the cycle is driven by raw heat and relentless wind. It happens every single moment. The planet also orbits a star that is a bit smaller and cooler than our Sun. An orange dwarf. Yet the heat is still enough to vaporize rock. This tells us that even relatively cool stars can create infernos just by being close enough. It expands our understanding of what planetary atmospheres can do. It is a reminder that the universe operates on physical laws that produce outcomes we never imagined. HD 189733b will continue its eternal cycle. The glass rain will keep falling sideways. The winds will keep screaming. The silicate vapor will rise, condense, and blast across the sky forever. It is a world of locked-in chaos, a perpetual engine of destruction. But it is also a world that exists because of simple physics. A star too close. A planet locked in place. And an atmosphere caught in between. The universe is full of such worlds. Each one waiting for us to measure its light, and to understand its hidden mechanism.